All right. Notes 2, measurement of rotation. So you guys are pretty good at this already, kind of. You guys are really good about degrees. It's the radians that we have issues with. So let's see what it says here. An angle is the standard position in Cartesian coordinate. All that means is XY coordinate grid. Its vertex is at the origin. Its initial side is along the positive horizontal axis. It is measured counterclockwise from a positive horizontal axis. The angle measure is positive, and clockwise from the positive horizontal axis. The angle measure is negative. Okay, relax. I'm going to show you what that means visually. So what that means is this. You have a grid, and you start at the origin there. So it's a positive x-axis, and this right here, and there it is. We count it, and that's 30 degrees. And it says, let's see, what else does it say? Clockwise from positive horizontal axis, the angle measure is negative. So that means that if I have this, so here, start at the origin, and if I go like that, that's a negative 30 degrees. Make sure to put a degree symbol. This is the Greek letter theta. So don't freak out. It's just like saying X. Nothing crazy, right? Okay. So, all right, Cardinals. 1 revolution is how many radians? Okay. When you guys were in geometry, you studied circles. Oh, that's a pretty good circle. And the circumference of a circle, oh, you don't like that circle? The circumference of a circle was 2 pi times radius. So that is how you calculate the circumference of that circle. If this was a wheel, 2 times pi times your radius will tell you how far you travel if you do 1 revolution. Does that make sense? So 1 revolution is 2 pi radians. So let me write that down. 1 revolution equals 2 pi radians. And that's the one that you have the most trouble with. But relax. So if you do 1 revolution, how many radians is it? 2 pi. That's it. And if you wanted to, you could say 6.28, but that's rounding. 2 pi is perfect. Does that make sense? All right, what about in degrees? I think you guys are good about degrees. 1 revolution is how many degrees? What do you guys think? Yeah, 360. So this, you guys don't have any issues. Put a little degree symbol in the upper right-hand corner. That means degrees. So 1 revolution is 360 degrees. Cool or not cool? Okay, usually you label the grid, well, I guess in the beginning. So here's 0 degrees. I haven't moved. 0 degrees. Then here's 90 degrees. Every quarter is 90 degrees, right? 360 times 1/4 is 90. And then if I go all the way to here, that's 180 degrees. There's my linear line. If I keep going, that's 270. And then finally, 1 revolution, 360. Cool or not cool? If I do this in radians, here's my radian. 0, notice I didn't put a degree symbol. Pi over 2. Pi. 3 pi over 2. And 2 pi. Once you've done a whole revolution, that's 2 pi. How do we feel? Nothing crazy, have we? Have we done anything crazy? Okay. Here we go, guys. Co-terminal angles. Relax. It says 2 angles in standard position are co-terminal if and only if their radian measure differs by a multiple of 2 pi. That's if it's in radian. That is, phi and theta are co-terminal if and only if, and they give you this formula. Relax. I'm going to explain it. And then it says when that stands for an integer. What formula, though? What about in degrees? Okay. What that means is this. So let's do the radians first because that's what we're weak on. So if I have a radian, so I'm going to say this is my radian. And it's the angle from here to here. And I'm going to say that's pi over 6. Do you agree that if I start on this ray and I do a whole revolution, do you agree that that is 2 pi because I just did 1 revolution? Do you guys agree with that or no? Yeah, look, that's 2 pi, guys. So that's where the plus minus 2 pi comes, where n is an integer. It really just it means like how many revolutions have you done. So what's my formula for degrees? I don't want you guys to be a robot. So phi equals theta plus minus, and instead of 2 pi, what is 1 revolution in degrees? Yeah, 360, put a little degree symbol, and put an n. This will tell you the coterminals. Chab, I still don't understand what coterminal means. All right, let's explain it with degrees. So if I tell you that I do 390 degrees, that's 390, and I go from the center, bam, And we said that that was 390 degrees. Well, don't worry, I'll stop. That is the same as 30 degrees because you did a whole revolution, which is 360. And what's the difference between 360 and 390? 30. So 30 degrees and 390 degrees are coterminal. It creates the same ray. Does that make sense, guys? Okay. How do we feel? We're going slow, don't worry. Stop me if something doesn't make sense. Okay, here we go. Let's go to the next page. Reference angle. This is going to be super helpful when you are in physics. The reference angle of an angle in standard precision is the positive acute angle between the horizontal axis and the terminal side. So write this down for good notes. The reference angle is always positive, and it's always acute. I guess I could have just done it in one bullet. It's always a positive acute angle, which means, what does acute mean? Less than 90. Cool or not cool? Okay. So, what is my reference angle? It's always between the horizontal axis and the terminal side. That just means where it terminates, where my ray is at. Terminates. Where's the ray? Ray, question mark. That's all it means, so don't freak out, guys. So let's do a whole bunch of examples. Ready? Do you guys have your calculators? Let me turn on mine. Not that you need it, because you can probably do it faster than without a calculator. All right, so here we go. It says sketch an angle in 71 degrees, 133, 254, and 317 in standard precision, and calculate the measure of each reference angle. So 71 degrees, what quadrant are you in? Quadrant 1. You always start on the positive x-axis. So 71 degrees is like right here. Theta equals 71 degrees. And the reference angle in quadrant 1 is always itself. So I'm going to label theta r, that stands for reference, and it's also 71 degrees because it is already acute. Does that make sense, guys? Okay, nothing crazy, right? All right, 133 degrees. What quadrant is that in? Take your time. Yeah, it's in 2. So here it is. I'm gonna exaggerate quadrant 2. And 133 degrees, start at the origin, and I'm going to rotate like so. So I'm going to say that is 133 degrees. The reference angle is not 133 because that is bigger than 90. It's always with respect to the x-axis. The reference angle is this guy right here, theta r. I'm going to put an equal sign. The distance from the positive x-axis all the way to here, that would have been 180. So how do you calculate it? You go 180 minus 133. So I take my calculator, I'm going to clear this, and I'm going to go 180 minus 133. And I get 47. So 47 degrees is my reference angle. 47 degrees. You could also think about it as you're 47 degrees away from going to 180, if you want to think of it like that. Yes. Oh, because I want to figure out my reference angle. And so let me draw a brand new one. The distance from here to here, that's a linear line. See? That, you just went 180 degrees. So if I go from the positive x-axis to the negative x-axis, that's 180. But I didn't go all the way there. I went to 133 degrees. So I'm trying to figure out my reference angle. My reference angle is always between the horizontal axis and the terminal side, the ray. So here's my ray. And here's the x-axis. So how do I figure it out? 180 minus that 133 will give me the difference.
Oh, find out the difference between x-axis and the other side.
Yep. That makes sense?
Yeah.
Okay. Ask questions, guys. I can't read minds. It's okay. All right. Let's do the 254. That's bigger than 180. in case you're wondering, Chavez, why do you keep mentioning these numbers? 0 degrees is right here, 90 degrees is the y-axis, 180 degrees is the negative x-axis, 270 degrees is the negative y-axis, and 360 degrees is whole revolution. So where am I? 254? 254 degrees. It's bigger than 180, but smaller than 270. What quadrant are you in? Yeah, quadrant 1, quadrant 2, quadrant 3. You're in quadrant 3. That's quadrant 4. So I'm going to exaggerate quadrant 3. So here's quadrant 3. And I'm going to go, and from the origin, bam. I'm going to call that 254 degrees. Make sure to put a degree symbol. I'm trying to calculate, so check it out, Ochoa. I want to calculate this distance here. That's my reference angle. So you tell me, and it's okay, miss, it is a safe space. How would I calculate that? Yeah, from what? What to, from what, from what? The distance, so I'll explain it. The distance from here all the way to here was 254. So what is the distance from here to the x-axis? 180. So what am I going to subtract? From what? From, that's right, 254 minus 180. And that will give us your reference angle. So let's see, 54, 64, 74. I want to say that's 74 degrees, guys, but you guys check it. And there it is. How do we feel? Okay, so, hey. So now let's do the 317. That is larger than 270, but smaller than 360. What quadrant are we in? 4, the 4th quadrant. So here is my grid. I'm going to exaggerate quadrant 4. And I'm going to start like this. Positive x-axis all the way like that. Origin, bam. That in black is theta equals 317 degrees. I need to figure out what this in burnt orange is. That's my reference angle. I am that many degrees away from doing a whole revolution. So how would I calculate theta r this time? I subtract it from 360. So 360 minus 317 degrees. What do we get? 27, 37, 47, 57, 43. 43 degrees. That's your reference angle. I always call that theta r, put a little degree symbol, because it's a degree. If you don't put a degree symbol, it's a radian. They're unitless. It just means how far you rotate. How do we feel? Okay. All right. I think we're good, guys. You guys are doing awesome. All right. Example 2. And we're going to go slow. Don't worry. Finds an angle in each quadrant with a common reference angle with 204 degrees. So what it's telling me to do first is find the reference angle when I'm at 204 degrees. And then from there, I'm going to find a reference angle in each quadrant. So 204 degrees, what quadrant are you in? The 3rd. So you're going to go, you're somewhere like right there. That is 204 degrees. My reference angle is this one right here in sky blue. So I'm going to subtract it from 180. So 204 minus 180, I believe that is 24 degrees. So that's my reference angle. Are we okay? Okay. What they want me to do, look what it says. Look at the directions. Find an angle in each quadrant with a common reference angle of 204. So they want me to write a 24 degree reference angle in every quadrant. So I'm going to draw a grid. And I'm going to draw a 24 degree quadrant, 24 degree reference angle in every quadrant. That's 24 degrees. That's 24 degrees. It doesn't have to be perfect if you have a protractor. That's 24 degrees. That's 24 degrees. And I know you're like, Chad, but you said if I go clockwise, it's negative. I'm using my reference angle. Reference angle is always positive. Are we okay? All right. So what they want to know, in quadrant 1, what is this angle? Quadrant 1. Well, in quadrant 1, if I just count like this, that's just 24 degrees. So 24 degrees. In quadrant 2, what is this angle? What is that? Well, I'm 24 degrees away from 180. So subtract 24 from 180. 80, 70, 60, 150. So 156 degrees. Quadrant 3 was given. It was 204 degrees. Given. And quadrant 4. So I'm 24 degrees away from a whole revolution. So do 360 minus 24. 60, 50, 40, 336. 336 degrees. Yes.
I have one question.
Yeah,
That
ask.
comes back to us, like, 1924. Why do you keep by, like, wait,
Yeah, ask.
why do you keep by 180 to find, like, 204, 321?
Oh, so for quadrant 2 and quadrant 3, we use 180 because the reference angle is 24. So if I want to figure out what this angle is, this in black, I have to go 180 minus 24.
No, I mean, for, like all the way back to, like, step 1, it was to 240, take away 180 to find.
Oh, 204?
Yeah.
Okay.
Why do we use 180?
Because I'm in quadrant 3. So notice, look at this. Look at this burnt orange. From here all the way to here, that's 180. And then I went another 24 degrees. See? So if I want to figure out what that reference is, I go the 204 minus that 180 to figure out that reference angle.
204.
Is what they gave me. So I went 204 degrees, which I passed the 180. So if I want to figure out the reference, I got to go 204 minus 180. And that will give me my reference.
Oh, okay. No, I understand. Sorry.
No, you're good, miss. Don't apologize. I want you to ask questions, please. How do we feel, guys? Are we winning? Okay. Yeah, I'm still surviving. I'm not dead yet. I'm sweating like big time. There's a lot of heat coming out of this laptop. All right, let's go to the next one. Yes. Oh, you're good? Okay. So look at this one, guys. Sorry, guys. I'm thinking of a football player who used to. All right. So, hey, no yawning. That's a demerit. So this one says, no, I'm kidding. That's not a demerit. Sketch an angle 4,897 degrees in standard position and calculate the measure of the reference angle. You could, if you wanted to, go like this. 360, 720, and keep going until you reach 4,897. Is that the best way to do it? No. What do you think is the best way to do it? Take this, 4,897 degrees. In one revolution, how many degrees do I have? So I'm going to divide it by 360 degrees. So 4897 divided by 360. 4897 divided by 360. And I get that number, 13.602 with the 7s repeating forever. 13.602 with the 7s repeating forever. That 8 is rounded, but it should be 7 forever. All right, so now tell me this. I think everyone's okay with the 13. The 13 means that I do 13 revolutions. What is that 0.60277777777777777? That was fun. Do we know? Is that the reference angle? It's just 0.602? All right, let me do a side note. And I bet you everyone will get this side note real quick. If I tell you 1.5 hours, it's 1 hour and how many minutes? 30. How'd you do that so fast? 1 hour equals 60 minutes, and 0.5 means half an hour, right? So that 0.5, let's be smart, guys. That 0.5 is a percentage. It means half an hour. So, what do you think that 0.602777777 means? It's a what? It's a percentage of a revolution. Does that make sense? So let's write this down because you guys got to get better with number theory. 0.602777 with that going forever means that 60.277% of a one revolution. It probably sounds funny. 60.277 means that 60.277% of a revolution. No, that's fine. We're not English majors. How do we feel? Okay, so here we go. I'm gonna take my calculator and try not to round, guys. Try to make it perfect. So I'm gonna get rid of that 13. I'm gonna go minus 13 because I want to use whatever is stored in the calculator. And there it is. And I'm gonna multiply that sucker. I'm gonna go times a revolution, 360. Look what happens. I get a perfect 217. If you were to, that means that's how many degrees I do. If I were to go 0.602, 0.602777, and I were to multiply by 360, I would get a decimal. Yeah, it's practically 217. Use technology so you can get a perfect number. So 217 degrees. So that means this. I am in what quadrant? Not everyone at the same time, guys. I'm in quadrant 3 because it's larger than 180 but smaller than 270. So I look like that. Theta equals 217. And they want me to figure out the reference angle. So I go this like that. Theta r equals, and I do, what do I do, Ochoa? I subtract from 180. So 217 minus 180. So let's see, 20, 37. Is it 37 degrees? And there it is. How do we feel, guys? Okay. Yeah. Cool, very cool. Math life. 24/7. All right. So here we go, guys. So let's do a quick little reference here. I'm going to do a grid, and I'm going to call this degrees: 0, 90, 180, 270, and then 360. And then I'm going to do another grid over here, and I'm going to call this radians. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so catch up. So they want me to convert these radians to degrees. If I wanted to, I could say that 2 pi radians equals 360 degrees. We could. But the scale we want to use, you always want to use the smallest numbers because it's smarter to work with smaller numbers. So we're going to use this scale. 180 degrees is equal to pi radians. So if we want to go, and I'm going to write it here, if we want to go from radians to degrees, you multiply, so I'm going to put multiply by, let's see, I want to go to degrees, so we're going to go 180 degrees over pi. And I'm going to change my colors. If you want to go from degrees to radians, you multiply by pi over 180. Does that make sense, guys? All right. So let's answer these questions. Pi over 3. I want to turn this. Is that a radian or is that a degree? It's a radian. Look what it says here. I'm turning it into a degree. So I got to multiply it by what? 180 over pi. So I'm going to go times 180 over pi. The pi's cancel out. And 3 goes into 18 6 times. So this is 60 degrees. Or you can just type in the calculator. Pi over 3 times 180 over pi. How do we feel? Let's do the next one. The 2 pi over 3. I'm going to put it, does it fit over here? 2 pi over 3 times 180 over pi. The pi's cancel out. Double the 18. Oh, I can't do that. So 2/3 of 180. I want to say that's 120. Can you guys check? Here, I'll check. 2/3, because the pi's cancel out, times 180. And yeah, 120. We still okay, guys? All right, 4 pi over 3. I'm running out of space, so I'm going to do it over here up in the top. 4 pi over 3 times 180 over pi. What do you guys get? Pi's cancel out. 4/3 times 180. It's going to be a number bigger than 180. What is it? 240, yeah. Put the degree symbol, because it's a degree. All right, 5 pi over 3 times 180 over pi. What do we get? Pi's cancel out. 5/3 times 180. 300. And last one. That one's really close to 2 pi, right? Because if it were 12 pi over 6, it'd be 2 pi. So 11 pi over 6 times pi over 180. It should be pretty close to 360, but not quite. Like 300 something. 180 over pi. 180 over pi, sorry. What'd you guys get? 330. How do we feel, guys? Okay. All right. The SAT level 1 math used to be a very popular exam. I don't think it's here anymore, guys. But they used to ask questions like this, so that's why I put it in here. Maybe next year I'll just delete this question. Notice that this says 2.5 radians, but it doesn't have a pi. That's fine. So again, 2.5 radians. I'm going to multiply this by, let's see, what am I turning it into? A degree? So I'm going to go 180 over pi. And this time I am going to include the pi. So 2.5 times 180 over pi. And I get 143.239 degrees. 143.239 degrees. How do we feel, guys? Yeah, we're almost done, guys. We're almost done. Are we okay so far? Yeah. All right. So now we're gonna work with radians. We're gonna sketch these angles. Relax. It's not gonna be that bad. Sorry, guys. All right. Sketch these angles. So here we go. 0 pi over 2 pi, 3 pi over 2, 2 pi. If you wanted to, I've had kids before that they just convert everything to degrees. That is fine, but I want you guys to get comfortable with radians. All right. Pi over 3. That's the same thing as saying 1/3 of a pi. Is that larger than half a pi? Or is it smaller? It's smaller. It's 1/3 of a pi. 1/3 is 0.333, and 1/2 is 0.5 of pi. So what quadrant am I in? The first one, quadrant 1. So here it is. That is pi over 3. And my reference angle is also pi over 3 because it's acute. It's equivalent to 60 degrees. We multiply it by 180 over pi, 3 goes into 18 6 times. Are we okay? Don't worry, guys. We're almost done. All right. 2 pi over 3. Is 2/3 pi bigger than half a pi? Yes. Is it bigger than a whole pi? So what quadrant? The second. So I'm going to exaggerate quadrant 2. And I'm going to say 2 pi over 3 is like right there. So that is theta equals 2 pi over 3. Catch up to there, guys. Look how close you are. This is my reference angle right here. Theta r. So look, ready, Ochoa? So observe. What? No, don't worry. Don't freak out. Look at this. The distance from here to here. Do you agree that's pi? Okay, you see this in sky blue? If I go to the positive x-axis and the negative x-axis, that's pi. I rotated pi. So my reference angle, I already traveled 2/3 of a pi. How much more do I got to travel for me to be at pi? One, not, don't say one more. 2/3 plus what equals 1?
Oh,
Pi over 3. 1/3 of pi. So that has to be pi over 3. Do you guys see how we did it? If you don't want to do it that way, if you're like, Chav, I don't want to do it that way, I want to be a robot, then do this. You can just go like that. That's pi. So you can go pi minus, I went to pi over 3, and then just find a common denominator. You can say, well, my denominator is 3, so make that 3 over 3. And then look, 3 pi minus 2 pi, that's just pi. If you want to do it that way, you can. But I want you guys to be smart. You're just 1/3 pi away from a whole pi. Cool or not cool, guys? Okay, so now let's go to the next one. 4 pi over 3, or 4/3 pi. Is that bigger than a whole pi? But is it smaller? By the way, the 3 over 2 is 1.5 pi, if you want to turn it into decimal. But is it smaller than 1.5 pi? No, it is. 4 over 3 is 1.33333. So if you take a calculator, if you don't know, like, oh, I don't know. 4 divided by 3. And notice that it's smaller than 1.5. So what quadrant am I going to be in? Quadrant 3. So I'm going to exaggerate quadrant 3. And here is my 4/3 pi. Theta equals 4 pi over 3. And look, check it out, guys. Catch up to here. Catch up. Bring some fries. Look at this distance here. I know that from here to here, from the positive x-axis and negative x-axis, that would have been pi. So 3 pi over 3, that would have been pi. It says 4 pi over 3, so that means this theta r has to be pi over 3. Because 3 pi over 3 plus pi over 3 is 4 pi over 3. If you don't like that, Chavez, I don't like that. Okay, then do this. Go 4 pi over 3 minus pi, and then do common denominator, 3 over 3. And then 4 pi minus 3 pi, that's just pi. Keep the denominator the same, pi over 3. So there, I'm giving you 2 ways to look at it, guys. Cool or not cool? Okay. I think you guys are going to like the next two. 5 pi over 3. So that is more than 1.5 pi, but less than 2 pi. See, 5 divided by 3. 5 divided by 3. 1.6. So it's bigger than 1.5 pi, but smaller than 2 pi. So what quadrant am I in? Quadrant 4, guys. So I know we're getting tired. So it looks something like this. That is 5 pi over 3. And again, you are pi over 3 away from 2 pi. Because if it were 6 pi over 3, that would be 2 pi. And I did this on purpose. They're all pi over 3 here. So theta r is pi over 3. See? All right, one more. And let's see if you guys can do this one. 11 pi over 6. So it's almost 2 pi. So you're still in quadrant 4. So I'm going to exaggerate quadrant 4. Here is my revolution. And bam. That is 11 pi over 6. How far away are you from doing a whole revolution? 1 what? 1 pi over... Did he say 6? Yes, yeah. Theta r equals 1 pi over 6. 11 pi over 6 plus pi over 6, that's 12 pi over 6, guys. And 12 pi over 6 is 2 pi. Do you guys see how we did it? Yeah, there's a safe space, guys. Don't ever be scared to say a number, or it's okay to be wrong. All right, here we go. Last ones, and then we'll set you guys loose with the activity 1. We'll talk about it. All right, all we're doing is converting degrees to what? Radians. So we go to our notes, and it says here, I wrote it here in black, that if I want to go from degrees to radians, I multiply by what? Pi over 180. So I'm going to come over here, and I'm going to go 495 degrees. And I'm going to multiply that by pi over 180. Now, because I want the exact answer, I'm going to leave it in terms of pi. So here's how you type it in the calculator. So in the calculator, do it like this. Go, I'm going to push clear and push 495 divided by 180. Don't put the pi in there. Push enter, and I'm going to turn that into a fraction. Child, how do you turn it into a fraction? Push math, enter, enter. It's the very first one, frac. And just put the pi next to the 11. See, I got 11 over 4. So this is 11 pi over 4. If you wrote the decimal, it's still correct, but the decimal is the approximate. The pi is the exact. Does that make sense? Look, this one you'll probably understand without even a calculator. 1 revolution is 360, so 720 for you, those that are skaters, that's 2 revolutions. In radians, if 1 revolution is 2 pi, this better give me 4 pi. And sure enough, if you go 720 divided by 180, it will give you 4. 720 divided by 180. See? 4. And then just put the pi. All right, letter C. 60 degrees times pi over 180. I know that 6 goes into 18 3 times. So this is pi over 3. No more degree symbols. It's a radian. Are we okay, guys? Okay. I take the 165. I multiply it by pi over 180. And let's see what I get. 165 over 180 turn into a fraction. 165 over 180. And math, fraction, enter. 11 pi over 12. Right. I want you guys to have a good sense of numbers. So I'm going to go really slow with this one, guys. So everyone pay attention real quick. 165 is 15 degrees away from 180. Do you guys agree? So is 195. 195 is 15 degrees away from 180. So if 165 is 11 pi over 12, what do you think 195 is? What do you think it is? It's bigger than 180. This was 11/12 of pi. At 180, it's 12 over 12 so of pi. So this has to be 13 pi over 12. And sure enough, if you go 195 over 180, if you don't like that, guys, if you were like, I don't like that, Chavez, then just do 195 over 180, turn it into a fraction. And there it is, 13 pi over 12. All right. Finally, the 120. 120 degrees times pi over 180. I know that 6 goes into 12 twice, and 6 goes into 18 3 times. So this has to be 2 pi over 3. How do we feel? Okay. All right, guys. I did the odd problems with the other classes. I didn't do all of them. Well, it depends. With one class I did. But I'm just going to do a few until you guys are ready, and then I'll let you guys loose. Cool? All right. So look at number 1. So I guess let's read the directions first. For problems 1 through 20, sketch an angle in standard position, mark the reference angle, and find its measure. Okay. So number 1, pi over 5. Well, that's smaller than half a pi. So what quadrant am I in? Quadrant 1. It's something like right there. It doesn't have to be perfect, guys. That's pi over 5. And my reference angle, because it's in quadrant 1, is also pi over 5. Are we okay so far? Okay. Any questions? Don't worry, don't worry. Number 3. I should have looked at it. 6 pi over 15 reduces. 3 goes into 6 pi twice, so 2 pi. And 3 goes into 15 5 times. 2 pi over 5. 2 pi over 5, is that quadrant 1 or quadrant 2? So 2 over 5, is that more than half or smaller than half? Smaller, so what quadrant? 1. So probably something like that. Don't have to be perfect. 2 pi over 5. And theta r is also 2 pi over 5. So far we haven't got anything funny. Okay, here we go. Number 5. And I'll go slow. Number 5 says 39 pi over 20. Look how close 39 pi over 20 is to 2 pi. If it were 40 over 20, that would be 2 pi. Do you guys agree? So I am in what quadrant? The fourth, guys. I almost do a whole revolution. I'm like this. So I'm like this. You're like something like that. You're super close. That is 39 pi over 20. And what's my reference angle? My reference angle is this guy. How close are you to a whole revolution? Pi over what? Yeah, I heard it. Say it loud. Pi over 20, guys. 39 pi over 20 plus pi over 20 is 2 pi. That will give you 40 pi over 20. That's 2 pi. Cool or not cool? Okay. Number 7. Negative 5 pi over 21. Oh, child, what's going on here? It's negative. Just go clockwise. So here it is. Clockwise. So I'm going to go like this. It's not perfect. Not even remotely close to perfect. I'm going to call that negative 5 pi over 21. And I'm going to say that the reference angle is never negative 5 pi over 21. I just turned it into a positive. Are we okay, guys? Okay. Now this one is really close. Negative 25 pi over 17. Okay, so I'm going to do a grid. 0 radians, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi if you do a whole revolution. In case you're wondering, that negative 3 pi over 2 is the same thing as negative 1.5 pi. I'm going to take my calculator. I'm going to do 25 divided by 17. 25 divided by 17. Notice that you get 1.47. So you have negative 1.47 pi. So negative 1.47 pi, what quadrant are you going to be in? Remember, you go clockwise. You're going to be in quadrant 2 because you go clockwise. You don't pass negative 1.5 pi. Like that. Does that make sense, guys? So that is negative 25 pi over 17. Now I got to figure out my reference. So I'm going to come over here. This is my reference angle. Theta R. Remember that the reference is never negative. So I'm going to pretend like this is negative 17 pi over 17. And that will give you the negative pi. So what is the difference between negative 17 and negative 25? I'm just going to turn it to a positive, by the way. So 5, 6, 7, 8. Is it 8? I'm just doing the difference between 17 and 25. So my reference angle is 8 pi over 17. Yes. Oh, remember, because it's negative, I have to rotate clockwise.
Oh.
That is negative 25 pi over 17. This guy's negative pi. I need a common denominator. So I turn it into negative 17 pi over 17. That's still negative pi. Then what's the difference between negative 17 and negative 25? It's just 8.
But why do we use the reference angle?
Oh, because it's asking for a reference angle. The reference angle is always with the x-axis. Yeah, it's a cube. 8 pi over 17 is smaller than 9.
Oh, okay.
It's a cube. It's always with respect to the x-axis.
Oh, okay. That's why I'm confused. I thought that was yeah.
You're good? Yeah, ask. Let's ask. I want you to ask. How do we feel? All right, let's go to the next page. I think you guys are good with degrees. I think. Negative 295. So here's my grid. 0 degrees, negative 90, negative 180, negative 270, and then one revolution, negative 360. So negative 295, what quadrant am I going to be in? Quadrant 1. I go clockwise, I'm right there. That is negative 295 degrees. And my reference angle is this guy right here. I've almost done a whole revolution. So I just go 360 minus 295, which I believe is 65 degrees. The reference angle is always positive. So that's why I don't bother to do like negative stuff. Are we okay? Okay. 98 degrees. There used to be a boy band called 98 Degrees. Tell your parents about it. They probably know. You guys probably don't. 98 degrees. What quadrant am I in? The second, just barely. You're like right there somewhere. This is a 98 degrees. And be careful. The number one mistake is that you guys tell me the reference angle is 8 degrees. The reference angle is not 8 degrees. The reference angle is always with respect to the x-axis. That's your reference angle. So do 180 minus 98. What's 180 minus 98? 82? 82 degrees. How do we feel? All right, I think you guys are going to be good at number 15. I will help you with number, you guys tell me, 17 or 19? I'll do one of the two. 19? Okay. That one says negative 2746. So you take this, negative 2746 degrees, and I'm going to divide it by 360. So negative 2746. So let me clear it. Negative 2746 divided by 360. Push enter, and I get negative 7.627777778. Negative 7.62777. It actually goes on forever. That 8 is just rounded. Okay. So remember what I did, guys. That means that you did 62.7% of a revolution. So I'm going to add 7 to get rid of that negative 7. So I'm going to take my calculator. I'm going to go plus 7 to zero it out or to cancel it. And now I'll take this and I'm going to multiply that sucker by 360. And there it is. Negative 226 degrees. So negative 226. What quadrant is that? 0 degrees, negative 90, negative 180, negative 270, and negative 360. Yeah, it's going to be in quadrant 2. Because, what was it again? I already forgot it. Negative 226. So it's between negative 180 and negative 270. So it's somewhere like right there. Theta equals negative 226. All right, here's my reference. Theta R equals, and then I just do 180 minus 226. So let's see, 26, 36, 46. I want to say it's 46 degrees. You guys see how we did it, guys? So do you guys think you guys can tackle the rest and turn it in before the end of the period? Awesome, guys. You can work together. Work together, guys. And then I'm here too, so if you get stuck, let me know.